but maybe it just hasn't stored yet.
Hi, everyone. I see someone was unmuted. We are going to be starting at 5 o'clock, so bear with us for a couple more minutes. Welcome to GMU Observatory. We've got the telescope open and looking forward to sharing our view of the night sky with you tonight. Hi, good evening, everyone. Welcome virtually to George Mason University Observatory. I'm Dr. Peter Plavchan. I am the director of the observatory. I'd like to tell you a little bit about us before we get started. We are going to be having some public nights coming up in February on alternating Wednesdays at 7 p.m. We also have a monthly free newsletter, The Moon. If you're in a giving mood this holiday season, we have the patrons of the observatory. Join now. Your donation will be tax deductible and support the outreach we do here. And if you'd like more information about any of these topics, you can reach us at science.gmu.edu/observatory. You can follow us on Twitter at GMU Observatory, or you can email us at gmuobservatory@gmail.com. You're all here tonight for a special event, the conjunction of Jupiter and Saturn. The last time they were this close in the night sky was nearly 800 years ago, I think in 1220 something, the Middle Ages. So just to tell you a little bit about the event before we get started, we have some clouds tonight. We have seen Jupiter just barely through the clouds. We're hoping for a break in the clouds tonight before Jupiter set. We don't have any special activities planned tonight besides just showing you our telescope and looking through it. We do have an image that we took last night that we will show you if we don't get to see anything tonight at all. But Jupiter and Saturn are still fairly far apart from one another. It's just they lie along the same line of sight. Saturn being about another billion miles or so further away than Jupiter. And because they're so close on the night sky, how close are they? If you were to go outside right now and look towards your western horizon where the sun just set, a little bit northwest, you would see two very bright stars, and depending on your vision, you might not be able to tell them apart. The angular resolution of a typical eye is about 1 arc minute. What does that mean? If you take 1 degree, an angle of 1 degree, and split it up into 60 pieces, we have each one of those is 1 arc minute. And so Jupiter and Saturn are just a few arc minutes apart. So by eye, most people can tell that they're two separate planets in the night sky, but they are fairly close together. I was looking last night and I could barely tell by eye that they were two different quote unquote stars in the night sky. Of course, they're not stars, they're planets. They are really bright. You do not need a telescope or binoculars to see them in the night sky. And over the next couple of nights, they'll still be pretty close. So if you're clouded out, go outside tomorrow night or the night after, right after sunset, look towards the west after the sun is set. up until about 6 p.m. Eastern time, and you should be able to see them getting further and further apart from here on out. So let's get to it. I'm going to switch my screen share here and show you a virtual view of our observatory. There we go. I have with me tonight William Matzko and Patrick Newman and a number of other students. This is a view of our observatory. As you can see, it is still fairly bright. The sun set a little over half an hour ago. And we have 3 views of our webcams that we have at the observatory. We put them in place serendipitously before the pandemic hit. They've come in incredibly handy. This is our control room. You can see no one's there right now. And we're showing you a live view of a computer that's sitting on the desk over here in the corner. If we go to inside the dome, here's our telescope. This is a live view as well. It's currently pointed at Jupiter and Saturn. You can see through the opening in the dome of the telescope that's still pretty bright out. So you're not missing much yet. And you also see some clouds. But we've got the telescope pointed and tracking at Jupiter and Saturn. So the light comes in through the opening of the dome, goes through the long white tube, bounces off a big mirror near the black ring at the back, bounces off a little mirror at the top of the white tube, and then comes back through the big mirror, through a hole in the big mirror in the middle, and to our detector here on the back right of our telescope, where we can make monochromatic, aka black and white images of the night sky. And Jupiter and Saturn are close enough tonight that we can see them both, if the clouds aren't in the way, with the same camera and without having to move the telescope. Up here, you see this reflective glass surface. That's actually plexiglass, and this is actually the motor, one of the 2 motors that helps control the pointing of the telescope tonight. We got another view here. This is our all sky camera. And I believe this dot that you see just peeking through the clouds is the moon. Just peeking through to give you an idea. So the clouds tonight are fairly thin. That's the good news. And we should be able to give you a decent view, provided we get a decent break in the clouds. So we're looking at the bottom of this all sky image. Let me just zoom down here. And you can see the clouds are a little bit thicker in that direction. We're just hoping that we catch a break tonight. So this is, we're looking at a fisheye camera, and the we're seeing horizon to the horizon towards the south with this view. We have one more view of the webcams before we get to our digital camera view, live view. This is a view looking to the dome. For a sense of scale, there's a door. And we're on the roof of Research Hall on Fairfax campus of George Mason University, and one of the iconic structures here on our campus. As you can see from this view, we are looking at clouds, but if you look towards the horizon, there's still some sunlight coming through. So we're hoping these clouds are going to move over. They're traveling from west to east right now, and hopefully they'll pass over us, and then we'll catch a break to see Jupiter and Saturn any minute now. Hi, sorry about that. We're doing this live. Can you hear me, William? Just a quick check.
Yeah, I can hear you.
Yeah, so I apologize for that. My network connection just died for a brief second. Let me reshare my screen. There we go. Looks like it's overwhelmed. I don't know why, but happy to be here. And happy to be back. I was a little bit worried there that the network on my end went down. So we're looking through some clouds. And so let's go ahead and show you our live camera view at the back of the telescope. There we go. It's being a little bit slow for me. Go ahead and minimize this. We can see the moon is poking through a little bit better now. That's some good news. And here we are. I'm going to go ahead and stop this exposure so I can explain what we're looking at. Again, we're doing this live, so I apologize for any technical difficulties we encounter. We're doing our best to pull together this event. I just turned in grades, so that's good news. So at the moment, the sky has gotten nice and dark. And so I'm going to switch over to a different filter to see what the sky looks like, and hopefully we'll catch a view even through the clouds and see Jupiter poking through. So bear with me. So this is a view of our digital web camera. It's very similar to cameras that you have in your cell phones, except the pixels are physically larger. We cool it to a temperature of minus 30 Kelvin to eliminate the detector noise and artifacts that are present in images that normally get processed out and you don't see them. But yeah, unfortunately at the moment, we are still looking through a decent amount of clouds. So you're gonna have to stay with us and we'll keep working on it here. Sky's still pretty bright too. So let me move this over here. To my trained eye, we might be seeing Jupiter there, but I'm going to keep taking a look. So while we are waiting, feel free to ask questions in the chat, and we'll take questions while we're waiting for a break in the clouds. But thank you all for joining us tonight. It's great to see all the interest in this event. Let me show you, while we're waiting, a brief view of our night sky. This is a virtual view of our night sky and where things are located. Right now, Jupiter and Saturn are towards the west-southwest. Sorry, I said the wrong direction. I said west-northwest originally. West-southwest direction. If we zoom in on Jupiter and Saturn, we can get a live simulated view of what we should be seeing. There they are. There we go. So they're fairly close in the night sky. And we'll be able to see a number of the moons if it clears up enough. And one of the things we'll be looking for are Callisto, Io, Ganymede, and Europa will form a line in the sky aligned with the spin axis of Jupiter. And Saturn's moons are a little bit more scattered because we're viewing it at an angle. And we have our first question. Since the planets are so far apart, shouldn't we be able to see them for more than one night? That is a great question. The answer is yes. It just so happens that their closest approach to one another on the sky was today, but tomorrow, the day after will be just as good. They'll be drifting a little bit further apart each day. And they were close, plenty close last night and over the past couple of weeks. They're close enough now that we can squeeze them into a single detector. All right, so let me take another image here with our digital camera, see what we've got. Not much. I'm going to repoint the telescope because it looks like we've drifted a little bit. That was probably on purpose on my part to align it earlier, but let's repoint it now. And now we won't know whether we're looking at it or if we're looking through clouds. 1 second, let's take another look. Sky's still pretty bright, but it's getting darker every minute. And looks like we don't have it yet. Still clouds. Let's go ahead and take a look at our webcam. So the moon is in the clear now. There's some good news. And the sky is getting darker, but we're looking off towards the bottom here at this patch of the sky. And so you can see that we're still looking through a decent amount of clouds, which will hopefully break up and pass through over the coming minutes. Such as the luck of doing astronomy, sometimes you just have the weather getting in the way. Okay, back to our webcam view. Just taking a look at the cloud coverage. You can still see it moving through. It looks like if we keep watching, we might catch a break in a cloud. So I'm going to go ahead and set this up so that we can take exposures regularly, and we'll see if we get lucky. And once again, if you have any other questions about Jupiter and Saturn tonight, feel free to ask them in the chat. Still looking at a decent amount of clouds. So right now we basically see a flat structure. You see lots of little circles, and those are artifacts on our detector. These are blank spots. These are either bad pixels or some debris in front of the detector blocking the light from hitting. So right now we're just seeing evenly illuminated detector, which is pretty much what you would see if there were clouds. So the next question we have is, if we look up at the moon, which way should we look in order to see Saturn and Jupiter? That is a great question. So if you're looking up at the moon right now, and that the moon is more or less towards the south, you're going to want to look towards the west, south, west southwest, where the sun just set. So unfortunately right now, the clear patch of sky is towards the east, which is in the top of this image. And the cloudy part of the sky right now is exactly where we want to look. Astronomers are used to that happening all the time. So yes, so right now, basically, if you look directly at the moon, Jupiter and Saturn are going to be towards your right. So the sky is continuing to get darker. Let's go ahead and switch over to our live view and take another exposure. And maybe we'll get lucky and catch a break in the clouds. They're pretty thick in that direction, but Jupiter and Saturn are very bright, so we don't need too much of a break. Even thin clouds, we'll still be able to see Jupiter and Saturn through that. And you can see that the sky is continuing to get darker, which is great news, which means we'll be looking through less and less reflected light and light pollution. So that's looking better. I'm going to go ahead and set this up to run in auto mode, and we'll continue taking questions, and we will just hope for the best at the moment. Sorry about the clouds. It's completely beyond my control. We do have some other live feeds, and I'll ask William to post a link to that live feed in the chat. And so if you'd like to go and see a live feed at another location where it isn't cloudy, we'll paste a link to that in the chat as well. The clouds are moving fairly fast. That's the good news. Okay, still clouds. It's probably the most exciting time you've ever felt about looking at clouds. Looking at the weather map, it looks like we're in the clear still. We don't have any precipitation in the area. That was also a concern tonight. But it looks like the closest precipitation is still fairly out west, out towards Winchester. Okay, go back to our webcam view. Still hoping there's a break up ahead. Hang in there. Okay, so good question. What is the closest these two planets have ever been? There is actually a time where they've actually overlapped. Jupiter passed in front of Saturn, and that was tens of thousands of years ago. So humans may have seen that, uh, uh, but it's been a long time. So generally speaking, Jupiter does lap Saturn every so often, but the precise alignment of their orbits means that this is the closest they've been in, as you've heard, nearly 800 years. But they have, in fact, been closer. But it's a fairly rare occurrence, and the main benefit is that they just appear very close in the sky, and that in and of itself is majestic. It's really neat too. It shows that science works and that you can predict when these events will occur. We do have some images from last night, and if we continue to not have any good views, we'll bring some of those up and show them to you. So maybe I will do that while we're waiting for a view. So these were some of the views that we took last night. Let me go ahead and bring one of these up. So here's one of our views from last night. This will be nice to have side by side too, just in case we do see Jupiter and Saturn tonight, and we can actually see that they've moved relative to one another. Basically, Saturn, it looks like it's to the right of Jupiter at the moment. Let me just move this out of the way. It's being fairly laggy for me at the moment. All right, so in this view that we took last night, we have Jupiter in the X here on the right, and you can see 4 of Jupiter's moons, and I don't know which is which because they have fairly short orbits, less than a day in the case of Io. And you can see Saturn in the upper right here. And so what I'm going to do now while we're waiting for the clouds to clear, I'm going to adjust last night's image and try not to get confused with tonight's image. And we'll zoom in on each of these objects. So here's Saturn, and it's blasted. It appears very bright because Saturn's pretty bright. So if we adjust the way in which we map the brightness to the grayscale intensity on the screen, we can take a look at Saturn here. Oh, hey, we caught a break in the clouds. There they are. Let's take a look. I'll stop what I'm doing. Let's stop. And they're gone again. Ah. Okay, well, there it was for one frame. You can see Jupiter. So maybe we're going to get lucky here and we'll give it a few more frames. And again, feel free to post any questions in the chat. We'll take them and answer them as they come in, as we have time. Oh, man. All right, well, we'll set it up to keep watching. It was just one frame. All right, well, we'll keep an eye. The sky has gotten dimmer, so I'm going to increase the exposure time. And that'll give us a better chance of seeing it as well. Here comes the next exposure. And still clouds. All right, well, while we're waiting for Jupiter and Saturn to reappear, I'll go ahead and move the window back out of the way. Jupiter was there for about 2 seconds, long enough for a slight crack in the clouds there. I'll let that run a few more frames. We had a good question about telescopes for beginners. We'll come back to that question in a little while. And let me just move this over a little bit. So we're looking at, if you're just joining us, we're looking at a live view on the left of clouds. But this is our telescope is pointed at Jupiter and Saturn, and we're expecting to catch a break here before it sets to the horizon. At the moment, just a quick check here, Jupiter and Saturn are 16 degrees above the horizon. So we have about another hour in which to catch a break in the clouds before they set. But here's their live view in our virtual sky right now, showing where they are in the night sky. Go back to our real view on the left. And this is an image on the right of Saturn from last night. Now go ahead and zoom out. And now we can see Jupiter here as well. And we'll go take a look at Jupiter. Seem to have, there it is. And again, Jupiter is much brighter than Saturn is. It's partially has to do with the fact that it's closer. You can zoom in and actually see some of the bands on the equatorial regions of Jupiter. Now, if you might be disappointed by seeing this view of Jupiter, please keep in mind that this is from a ground-based telescope. And when you've seen pictures of a Jupiter and Saturn in the news, those are either from the Hubble Space Telescope or taken with the Voyager flyby, or the Cassini mission, which went to Saturn, or the Galileo mission, which went to Jupiter and took many up close pictures. And right now the Juno mission is in orbit around Jupiter as well. So here's Jupiter from last night, and just to zoom out again and show you the two relative to one another, you can see how much brighter Jupiter is than Saturn here by my cursor. There's Jupiter, there's Saturn. And so if we increase the contrast in the image, and this is a mathematical way of mapping the brightnesses to the grayscale intensity on the screen, that with the right combination, you can see the much fainter Galilean moons. Now, it's actually a lot easier to see the Galilean moons with your eyes if you have a telescope, because your eyes actually see things logarithmically, meaning that it can see a wider dynamic range than a digital camera can. So you can see right now that Saturn appears so close on the sky, it's actually not much further than the Galilean moons of Io, Callisto, Ganymede, and Europa. We have a curious thing. Can we see what a regular picture of the moon looks like through the telescope, since it's so much closer? I'll tell you what, I don't want to miss an opportunity to see Jupiter and Saturn right now, but at the end of tonight's broadcast, the moon will still be up. And so we'll take a look at the moon after we wrap things up tonight with Jupiter and Saturn. Unfortunately, let's take another quick look at the clouds. That gap is getting bigger. So we're almost there to a break in the clouds. So bear with us. We should get a nice view of the clouds coming up soon. Thank you for your patience. I'll tell the clouds to hurry up and get on their way. Now, in this particular exposure, we don't see much in the way of Saturn's moons, but they are there. And we could look at one of our other exposures. This particular exposure was from last night, was in a filter called H alpha, meaning looking at a red wavelength of 656.3 nanometers, if you're familiar with wavelengths of light, but basically red color. And so we're not picking up Saturn's moons as well as we are Jupiter's moons, not to mention that Jupiter's moons are closer to us on the sky. So I'm going to go to another image now in a different filter, and you can see how that looks by comparison. So I'm now going to pull up a ultraviolet filter of Jupiter and Saturn from last night. And now Jupiter's so bright, it actually casts an internal reflection of the telescope around it there. But now we can pick up Jupiter's moons much more clearly. And if we go look at Saturn and zoom in on Saturn, the break in the clouds are coming. I hope it's worth the while, worth the wait. So Saturn's moons tend to appear a little bit further away. And in this particular exposure, I'm not seeing any. I think the exposure was just too short. But of interest here, we can zoom in and take a look at Saturn in this different filter of ultraviolet color. And it looks fairly similar to people that haven't seen Saturn before, but the surface structure and the relative brightness of the rings to the planet is different. And if I scroll down here to to Jupiter, and take a look at its bands, you might be able to tell that its bands look slightly different as well. You'll see some circular spots on our images, and those are artifacts of our detector. But the striping you see on Jupiter, that's real, and these are raw images taken with our digital camera. Cool. Well, I think that's enough for looking at yesterday's images. Now would be a great time to get a break in the clouds. Let's see how we're doing. Yeah, we've got a break in the clouds coming. Almost there. If we look at the all sky camera, it's gotten darker, so let's adjust the setting on our all sky camera. So you can see that it's fairly cloudy. The moon is also obscured now, but let's keep an eye on our view focused on Jupiter and Saturn. And so we're just going to pay attention to this for the next little while. So while we're waiting, we had a good question about what is a good telescope for beginners. It depends on the budget you have. There is a telescope for every budget you need. And it depends on how much patience you have. So for someone first buying a telescope and looking through a telescope for the first time, it's not necessarily as easy as you would think to be to point it at what you would like to see. And especially when you have a fairly high magnification with your telescope of about 100 or so, you're looking at just a tiny little pencil beam of the sky. And when you do that, it requires, if you're trying to find a particular star in the sky, you really need to have that telescope aligned with the particular point in the sky fairly well. And that takes practice and patience. We have another question. How can I locate Jupiter and Saturn using the moon as a point of reference? The moon currently is pretty much due south. The where to see Jupiter and Saturn outside right now, if it's clear in your location, is to look towards almost due west, a little bit to the southwest, at altitude currently of 15 degrees above the horizon. All right, so the background's gotten quite faint, so let me up our exposure time. Oh, you see this orange line creeping up. This is our horizon limit we're crossing, but that's okay. Our telescope can handle this. We're going to up our exposure time, and I'm going to make sure we're looking in the right direction. Yeah, we should be fine. Sorry, my remote desktop connection is being a little bit slow. There we go. Sky's nice and dark now. That's the good news. When do they set tonight is the question. It's around 6:30, depending on how clear a view of the horizon to the west that you have. And if you're wondering how to find it from the moon's about south. You want to basically trace from the moon towards where the sun set. Pretty much Jupiter and Saturn follow the sun at this point in time in terms of where they are. And pretty soon, in another month or so, the sun will come between us and Jupiter and Saturn. You won't be able to see them at all. Looks like we are getting a lot of clouds still. We're seeing a lot of changes in brightness variation. And hopefully that will change. Maybe that could mean we're coming up on a cloud edge. Fingers crossed. There we go. Take a look. Let's double check something. I'm bringing up the camera control interface again. There's Jupiter and Saturn. We have a break in the clouds, everyone. Hopefully it lasts. Okay, so we are off to the right. I'm going to move the telescope a little bit to recenter Jupiter and Saturn. I'm going to wait one more exposure. There they. Oh, finally. Hey. All right. Are we saturated? We are a little. We're just barely not saturated. So we finally got a nice view. There's the Galilean moons, Jupiter and Saturn. We're going to pause the exposure here, take a shorter exposure, and give you a view. Thank you for your patience tonight for the past half hour, but we got it. All right. So Jupiter is so bright, it's just blasting away our detector at the moment. And maybe we're seeing some scattered light still from the clouds as well. I'm not entirely sure. Haven't really seen this kind of pattern before. Waiting for this 3-second exposure to come out. Bear with me. And we hit some clouds again. Shoot. Let's try one more time. I should have just kept that one image up. There we go. I'm just going to stop right there. Let's see. Jupiter is saturated, but it's not too bad. But you can see the 4 moons. Actually, strangely not picking up any of Saturn's moons. If we look at our virtual view here, we might be seeing Hyperion. Titan should be up there. So let's go and take a look. The view is slightly rotated right now. So this haze you see is not real. It's mainly because Jupiter's too bright. Even on the oops, I got muted. Sorry about that. Unmuting myself. Hey, Will, just checking. Can you hear me okay?
Yeah, I can hear you.
Okay, great. So I'm going to go ahead and zoom in on our live view of Saturn. There it is. A nice zoomed in look at it, except it keeps disappearing on me. So there's our view of Saturn. You can see the rings. You can see the gap between the planet and the rings. Something a number of scientists figured out, including Cassini. When Galileo first observed Saturn in the 1600s, early 1600s, he thought they looked like ears, but we eventually figured out they were rings. If we zoom out on Saturn and up the contrast, let's see if we can pick out some of its moons. There we go. There's some of its moons. So that moon right there, according to the virtual view of our night sky, is Titan. So this little smudge is a world that's larger than the Earth's moon. And actually, is that correct? I think Titan is, but it is the only moon in the solar system with an extended atmosphere of nitrogen, an atmosphere that is in fact very similar to the atmosphere of the Earth, which is also mostly made of nitrogen. And but you wouldn't want to go there just yet. While it does have lakes and rivers, and that has been imaged with the Cassini mission, and we saw some rounded pebbles when we landed the Huygens probe on Titan. It's really, really cold, and those lakes and rivers are made of methane and not water. In fact, water there is ice. In other words, water is a rock. So there are water mountains, ice mountains on Titan. And let's see if we could pick out any of its other moons, mainly over here in the lower left. I'm not seeing any in this exposure. We'll probably need to take a longer exposure to come try to do that later after we can look at Jupiter and its moons real quick. Jupiter is blasted away. We have too long of an exposure there on Jupiter, but you can see very clearly its moon Europa off to the right. And then if we go to the upper left, we have Ganymede over here, Io, and further up to the right should be Callisto. I have to zoom out a little bit. Maybe I just got it slightly. So we're only seeing 3 of the moons at the moment. So that must be Io and Ganymede. Now Callisto must be further away. It's not showing up at the moment. That's odd. All right, well, let's take another exposure and see if we can avoid saturating on the planets. And hopefully the clouds are still parting. Fingers crossed. Yes, okay, there we go. So there is Callisto, and then let me move this participant window out of the way. Io, Ganymede, and Europa. And so now we don't have Jupiter saturated, so we can go take a closer look at Jupiter live. And actually Jupiter is still saturated, super bright. So we need to do a shorter exposure. And again, if you have any questions, feel free to post them in the chat. Got people joining all the time tonight, a little bit hard to keep up. What was what you saw above Io? That's a great question. I believe that is a star. You might have seen one of these stars, not quite sure. It could have been this star here, could have been that star there, not entirely sure. Let's go back. And zoom in on Jupiter now. Hopefully it's not too saturated. Oh, it's still pretty bright. Okay. I don't think we could try doing an even shorter exposure. And then we'll do a really long exposure to bring out some more of the moons. I appreciate all of you joining. I hope you're all healthy and safe during this pandemic. And please follow us on Twitter at GMU Observatory. Please go to our website and sign up for our newsletter at, oh boy, the clouds went away. It's even clearer now. And even this very short exposure is killing us with Jupiter. Okay, so maybe we'll get some good moons here. Let's take a look. So the clouds have parted even more so. But you can go to our website at science.gmu/observatory. You can sign up for our newsletter there. And wow, this is looking pretty good. All right, so we've got 0 counts there. Let's see if I can bring out some more contrast in the image. Yes, okay, so now we're seeing some more of the moons. See if I can bump that up even further. Yeah, okay, there we go. So Jupiter is blasting our digital camera. We're actually seeing an internal reflection of Jupiter. That's what this O, this big thick O is. But we got the 4 moons of Jupiter, and we see a star over here, and that's this star here, kind of making a triangle with Callisto and Io. So that is the star HIP 99385. Astronomers are really clever with our naming schemes. And if we go look at Saturn at the moment here and take a little bit of zoom in on our virtual live view, let's see which moons we can pick out of Saturn in our live view here. As I mentioned, we have Titan now showing up very nicely to the upper right of Saturn. It looks like to the lower left of Saturn, I don't know what moon that is. Maybe it's Rhea that we're picking up over here. And this is probably Hyperion. Oh, sorry, we just mentioned that. That's the HIP star. Let me make sure I've got that right. Yeah, okay, so we've got probably Rhea there. And that's about it. Let's see if I can draw. We could do a longer exposure and see if we can pull out some more. Try switching to some other filters. And then we'll just take some more exposures. Oh, great question. How long ago did the light that we are seeing leave Jupiter for us to see it? Well, Jupiter is located at about 5 astronomical units from our sun on average. Okay, let me adjust that stretch there. It looks like Jupiter is still super bright. And so one AU is about 8.5 light minutes. Now, at the moment, where we're at, we have to add about another AU. So it's about 6 AU Jupiter is from us right now. And so you multiply 6 by 8.5, it's around 50 minutes. So the light we're seeing from Jupiter actually left on its way to us about 50 minutes ago. And there we are. And Saturn, of course, even further, 11 AU, so that left 2 hours ago. That's a great question. Fun fact, one of the scientists that worked for Cassini, who discovered the rings of Saturn, by then they were actually had telescopes powerful enough to see the Jovian moons passing in front of Jupiter, causing eclipses on the atmospheric surface of Jupiter. And one of the things Cassini realized was that the timings of these eclipses weren't matching the predictions from Newton's law of gravity. And he didn't know why, and they kept collecting data. But one of the scientists he worked for figured out that this was because the speed of light is not infinite. And by carefully measuring the timing of eclipses from Jupiter's moons passing in front of Jupiter, we were able to measure the speed of light with an accuracy of about 5%. And so astronomy to the rescue there. All right, so I want to take another zoom in on this picture so we can get a better view of the moons we're looking at. But yeah, once again, we've got Titan in the upper right here. I think we're picking up a little bit of, and maybe one of the moons up to just to the right of the rings here. And then it looks like we have Nemesis off to the left of the rings. We've got a star there, and then Jupiter's 4 moons. And I can play with the contrast a little bit more, but even Saturn's super bright. So now I'm going to do a much shorter exposure now. here they are in the night sky, and we thank you for joining us tonight. You can see Jupiter and Saturn. You can see the rings of Saturn. You can see the moons of Jupiter with binoculars. And if you buy one tomorrow, you can see them tomorrow night. If you got Amazon Prime, we'll deliver it next couple of days. But pretty soon, Jupiter and Saturn will be behind the sun. Let me adjust the stretch here. It's my bad. And let's take a closer look at Saturn to see if we can pick out any more moons. But yeah, probably the best place to start in terms of being an amateur astronomer, AM or PM. I forget what the question was, Gregory, is about the AM and PM. What it was in regards to. Will, if you know, feel free to hop on.
I'm not sure what the question was.
Okay. All right, thanks. I zoomed in a little too much there. Lost my place in the sky. So as I was saying, it's binoculars are probably the best place to start. And if you want to buy something better than that, a small telescope, if you have patience, a telescope with an equatorial mount, either reflecting or refractive with lenses will do. You can get a fairly cheap one for like $50, a toy one, and those are a little bit hard to use because they're just too unstable. And so you end up having a really hard time pointing them. And so they're really only good for looking at things like Jupiter, Saturn, and the moon. If you don't have a lot of patience and you have the budget for it, my recommendation is for a computer-controlled telescope, such as one made by Celestron. And they're so fancy these days. Of course, you could spend $10,000 if you want, but the cheapest computer controls ones I've seen are around $400. And the beauty of these is that once you've aligned them, you can press a button to go to a target, and you don't have to worry about finding it yourself. And that, you might say, takes out some of the fun of it, and that's fair. But it depends on one's definition of fun, whether or not they have the patience to sit and point the telescope and learn the constellations and navigate the night sky. It's not for everyone. So let me just adjust the contrast here. We've got Titan again, but not much else in the way of the moons in this shorter exposure. We have a nice view of Saturn. We're going to zoom in on Saturn again, and I lost it. Bring it back. Doesn't like remembering where I pointed it at today. So there's Saturn. We're looking in a red filter. We'll go try a different filter soon, and hopefully you can see some of the differences in features. Now let's take one last look at Jupiter, and we'll take some more exposures and hope that the clouds have still held off. All right, so we're going to stretch this image now to get a good look at Jupiter. It looks like our telescope focus may be drifting a little bit now. There it is. Too much. And these little dots you see, these little circles, these are artifacts in our detector, which at the moment we're working on figuring out what they are and getting rid of them. But you can see a little bit of the banded structure here on Jupiter. So let's go back to another live view. There's Jupiter and Saturn together, just so you can have one more look at them. Then I'll blast it. So I'll change the contrast so you can see the moons as well. Yeah. So by the way, if you have enough money to spend, you can actually, for $300, they make a camera now that automatically figures out which way your telescope is pointed. Celestron makes that. It's pretty cool. So it can figure out where the telescope is how the telescope is aligned on its own, which is for the extremely impatient, is a way to uh, even make observing easier. All right, so let's take another look at the night sky, see if we still have no clouds. Also do a rain check and humidity check. Humidity looks fine at the moment. And the precipitation, well, I'll wait for that to load. Let's look at our all sky view. So you can see here that we still have clouds. Oh, that reminds me. I need to adjust my settings here. It's color compressing right now. Okay, set to high. Okay. Yeah, I'm adjusting. Yeah, so it's it's okay. Never mind. It's not color compressing. That's the good news. Just it's very, very dark out. Oh, this is a great question. Oh, the question is, are they low on the horizon now? You can see some moonlight reflecting off the clouds there in our night sky. Right now, at the moment, they are 11 degrees above the horizon. So we're starting to look through more of the Earth's atmosphere. And we definitely have some clouds, but we're still in the break. And if we look at this view, we can see we're still looking at a break in the clouds off to the west. So Jupiter and Saturn, fun facts. Jupiter has 300 times the mass of the Earth. But it's only about 10 times bigger in diameter. So it is a lot less dense than the Earth, but it's a lot more massive. Let's go back to our live view. And so it's big enough that the gravity is strong enough to hold all that gas together. And gravity keeps it roughly in the shape of a sphere. Because it's a spinning gas, it looks like we're looking through a little bit of clouds at the moment. Oh, you know what? I've figured out what I'm doing differently here. Because this cloud of this big lump of gas is spinning, that's actually slightly oblate. It actually has a thicker equator than it does its poles. But here we have a nice view of Jupiter and Saturn. Let's try another filter while we still can. We're going to go to a blue filter now. And I might get away with a longer exposure there. Fingers crossed. But yeah, gravity is strong enough. In fact, the sun is just gas. And it has the mass of 300,000 times that of the Earth. So without gravity, right, you would think gas would just dissipate, but there's the self-gravity of the gas itself that holds everything together. Our picture came in and it looks pretty good. Let's take a look at Jupiter and Saturn more close up. So you could tear apart Jupiter and Saturn if you had a sufficiently massive object like a star. And occasionally stars do eat planets if they wander too close, if their orbit is poor. We have another question. Thank you, Dr. Geller, for joining us tonight. We have a question. Do you think we could see anything from inside DC? Yes. Jupiter and Saturn are super bright right now. If you're talking about stargazing in general with a telescope, you want to get to as dark an area as possible. I mean, our campus is here on Fairfax University. You can see there's actually some lights in the background. We do have light pollution on our campus. And so we can actually still see plenty of celestial objects with a telescope. It's just you're going to get a better view if you go about an hour west of DC. That's a good question. Thank you for asking that. All right, so we're looking at a live view, and apologies, mine's being a little bit slow today. There we go. So we have Jupiter here on the bottom and Saturn. So the moons are moving a little bit. You might be able to tell if you have a good eye, but the moons are actually moving a quarter of an hour. You can actually see them move. If you come back tomorrow night, if we compare it to last night's image, let's go back to last night's image one more time. If you compare it to last night's image, not only are the planets in a different spot with respect to one another, but the moons are as well. Oops, let's go back here. So here's an image from last night. And so you can see that Jupiter is basically past Saturn, and they've reversed position. And last night we had 2 moons on the left and 2 moons on the right of Jupiter. And tonight we have 3 moons on the left and 1 moon on the right. A little bit hard to tell in this particular image. If I change the stretch a little bit, oh, we're not seeing one of the moons at the moment. Probably because the filter we're in is blue. What moon is it? Europa. So we're having a hard time seeing Europa at the moment. So maybe that's because it's not very blue. We can also try a longer exposure. Let's take one more and we'll see if the clouds have come in. I'm expecting the clouds to take things out again soon. Yep. Okay, so let me change the stretch here. I believe we are looking at clouds again. And so we'll be wrapping up this event soon. Let me just double check. That's right. Let me adjust that. I need to zoom out. We've got nothing there. Let's go back to a red filter. Continuous mode. Let's check the webcam. Yeah, there's the moon. So yeah, it looks like the clouds have come in again. And we're going to wrap up tonight with looking at the moon, if you're willing to stay with us, because it looks like the moon is still shining through some fairly thin cloud. Double check this other live webcam view. Yeah, okay, so the clouds have come in. We got it. They can't stay down just long enough tonight to see Jupiter and Saturn. That's really great. I'm glad nature cooperated with us tonight, especially with 140 people on tonight. Thank you all for joining so very much. Let's go to the moon. Well, maybe NASA will, but we're going to virtually take a look at it with our telescope anyway. I'm getting an internet connection unstable warning, so apologies if I got to zoom out some more. Apologies if my connection. So this is a virtual view of our night sky. We can see Jupiter and Saturn are fairly low to the horizon. Well, let's go take a look at the moon. Zoom out one more. There it is. Let's slew to the moon. So slew is just a fancy astronomer word for moving the telescope. We're going to go ahead and watch it turn. Go back to our 4x4 view, 2x2 view. We can watch the telescope turn. So thank you for joining us to see Jupiter and Saturn tonight. Hopefully it was exciting to see them in the sky. You'll probably see some beautiful pictures of Jupiter and Saturn posted on the internet in the next day or two. Many astronomers are looking at it tonight, and what they're doing is they're collecting the data and then processing it. We did that last night. So one of our students is processing that data as we speak to make a beautiful color image. And maybe I could figure out how to show that to you tonight. Go ahead and mute everybody, Will. Somebody's unmuted. All right, let me mute all. 1 second.
Oh, Peter, I muted you as well in that mass mute.
Oh, thank you, William. So here was the image that we took last night. Um, and this is a color image. And this is, we're still working on processing it because Saturn is much, much fainter than Jupiter. But we can go ahead and take a closer look at this image. And let's see if I can zoom in on it. Yeah, I don't know in Chrome how to zoom actually. Let's see, is that the only zoom I can do? Let me save it. I'm a Mac user, so this is my my limitation. We're waiting at the, we're gonna go look at the moon next. So thank you for your patience. Actually, it's still exposing. It's a little bit, let's stop that at the moment. Okay, are we pointed at the moon? Yes. The dome is turned in position. And 1 second, let me pull up this image and zoom in on it. I don't think this is this is an image from earlier, from a before the conjunction. Let me go grab the one from I just saved. I think I put it in a different folder. Oh, here it is. Yeah, here it is. So we can zoom in. So this was a color image, stacked image with lots of processing. But here you can see Jupiter from last night. And here you can see Saturn, a little bit dim, but we can adjust that. We'll be processing it. So if you follow us on Twitter, the images we took last night, we're going to continue processing them and post them to our Twitter in the coming days. So back to the moon. Okay. Oh, there it is. Yeah, so here's the moon. It's a crescent moon right now. Oh, dear Lord, what happened there? Oh, it's still in. Let's stop. We need a much shorter exposure. We're saturating the moon. But you can actually see it there. It looks beautiful. It's just too bright. Let me change filters. I need to hit stop. It looked pretty good there in one image because it was clouds had extincted it enough. And you just, there we go. Okay, so now we're going to do an exposure in H alpha. We're going to make this a little bit bigger. It's not the finished product. We're waiting for a new exposure to come out, and it looks like this machine has had enough for today. We're getting a spinning wheel here. That is not going well. It looks like we've crashed the program. So Will, if you wouldn't mind, slew me to the moon, yeah. Can you kill this Maxim DL and let's restart it?
Sure thing.
Might be a little bit hard to do because I put it in the full screen mode right before it started misbehaving. Oh, there's a nice view. We're going to restart it real quick. Thank you for your patience. Will, is it ready to restart or not yet?
Actually had a little trouble getting that to do what I wanted to.
All right, let's just leave it. I'm gonna stop it right now. I think the problem is that it's in continuous mode. And I just need to wait for it. It's lagging. It's updating the exposures too quickly. All right, so here's a nice view of the moon. We can go ahead and zoom in on it, and we've got a waning crescent moon right now. And what does that mean? It means that it's only partially illuminated. And just to give you an idea for comparison, look how it's filling our entire field of view here compared to what we saw with Jupiter and Saturn. That gives you an idea of how much bigger the moon appears on the sky in angle compared to the sun. You can see the dark side of the moon is to the left here. The illuminated side of the moon is still fairly bright. I'm looking at the counts here. It's actually not saturated. That's the good news. But we can play with the contrast and bring out some more of the features here. And so what I'm doing right now is I'm mapping the intensity of light that was recorded in our detector to the intensity that's being displayed on the screen. We have a beautiful view of some of the mare, the lunar mare, and don't ask me to name them because I don't know the names. We have plenty of craters that we can see. We can zoom in on some of those. And the region between dark and light is called the terminator. It's basically where sunrise and or sunset. This is a waning, so this is sunset on the moon is occurring. And zoom in some more. So it's actually a good time of year to look, or good phase of the moon time to look at the moon, because you can see the shadows cast from the craters. The dark side of this crater is in shadow, and then this high side of the crater still in sunlight. And so you can see many of these craters at the moment on the terminator. So we have a great question from the chat. Is this going to be saved and posted? Yes. We will post this to our YouTube channel after it's ready, and I'll download it. At least I'm pretty sure that it's been recording. Do you see? Yeah, it still says recording, I hope. Well, does it show as recording on your end?
Yes, it is.
Okay. And this is called the limb of the moon. That's just a fancy word for the edge. And I do sincerely hope that we do go back to the moon as a country in the next few years. I don't know if you follow news closely or not, but China has successfully landed a robotic lander on the moon. I think this was about a month ago. And it collected lunar soil, lunar regolith, and actually launched back into orbit of the moon and rendezvoused with the robotic orbiter. And that sample is on its way back to Earth. I don't think it's landed in China yet, or at least I haven't been paying attention. I don't know if the sample is landed back or not. But this will be a pretty exciting time to see what the US and other nations are doing, especially US with the private industry. Although it is exciting that SpaceX and Elon Musk have lowered the cost of access to space dramatically, they are also polluting the crap out of the night sky. So unfortunately, there's some good things and bad things with SpaceX. So their new Starlink satellite network, while it is providing fairly expensive internet access to the most rural parts of the world, it does come at the cost of polluting our night sky. And there's like zero regulation. The only approval that they needed to launch that satellite network was the FCC's, which governs the electromagnetic spectrum radiation, radio frequencies, Wi-Fi, cellular signals. But they didn't take into account any of the light pollution in the night sky. It's pretty much ruined the radio night sky at the frequencies it operates at, and that sucks. Plain and simple, that there's no US regulations and that a single US company ran by a billionaire can dictate what the night sky looks like for an entire planet of several billion people. All right, so I'm going to move the telescope around a little bit so we can take a little bit of a closer look at different parts of the moon. But that concludes our show tonight. Thank you all for joining. I hope you enjoyed our views. You know what? Actually, Mars, want to do one more thing? Take a look at Mars tonight while we're at it. Mars is pretty close in the sky. Let's take a look. Maybe we'll get lucky. All right, so grand tour of the solar system tonight. We've had horrible weather this semester. I mean, just to put things in perspective, the weather's been awful. So it's actually nice that the clouds parted long enough for us tonight to get a nice view of the night sky. Let me bring back our webcam. We can see the telescope moving again. You can see this giant fork turning. It's hard to get a sense of scale, but if you look at the bottom left view, that's a door. And we're there. So let's go ahead and take a look at the all sky camera. Will, I see some moisture approaching there's some rain in Front Royale, and the humidity is up to 83%. So we're still okay. If we look at the night sky camera, you can see Saturn and Jupiter are pretty much hopeless with the clouds there at the moment. But the moon and that part of the sky is still pretty much in the clear. It almost looks like the clouds are moving the other way now. They are. It's a little unusual. Usually it's a easterly flow, but now it's going, these clouds are going west. That's interesting. That caught me by surprise. So let's go ahead and take a look at Mars. Now Mars is going to be a little bit fainter. And so let's try that exposure. Oh, Kelsey, thanks for joining us. Let me mute all 1 second. So we had someone. So anyway, someone just joined us an hour late. Just so you know, this is recorded. We will be posting this to YouTube afterwards. Here comes Mars. There it is. Saturated it is. I need to run a shorter exposure. I believe Jupiter and Saturn have set by now. I'll go take a look later. We might go take a look. Yeah, it's probably hopeless at this point. Let's see, are we still saturated? Yeah, so I need to go even shorter. So for those of you that have just joined, in the direction of Jupiter and Saturn, we have clouds. We did get a look at Jupiter and Saturn earlier. We recently just went and looked at the moon. We're looking at Mars. Try one more time Jupiter and Saturn right before they set below the horizon, if we can. All right, so are we still blasted away? It looks like it. So let me zoom in. Yeah, so I need to go even to this filter. And let's try one more exposure. Maybe we'll get a good view, but that is Mars, and you can see that it's round, unlike a star. I'll show you what a star looks like. We've been looking at a lot of planets tonight, but I'll show you what a star looks like maybe at the end here, if we have a little bit of time. Still blasted. Wow, okay. Mars is pretty bright. So our detector counts photons. And it can only count so many. Now, how does it do that? Jupiter set time. Okay, so 8 p.m. All right, so maybe we'll still get it. That doesn't seem right. 8 p.m. I'll have to double check that. Here's Mars. Man, it almost looks like we're out of focus, but let's take a look here. Still a little saturated. Yeah, it's just super bright. It's still a little saturated, and I don't know why we shouldn't be seeing a crescent Mars. Something's not quite right there. I think the focus is a little bit off. But we do see the round portion of Mars. These are some artifacts on the surface, not on the surface, in our detector. But it looks like Mars is, it's actually not too bright. We're actually okay there. Okay, all right, this is okay. Let me go ahead and adjust the display on Mars. And let me change this a little bit different to bring out some of the detail. I think our focus is bad. That's my guess as to what's going on. Let me go ahead and try and clean that up a little bit. Thank you all for joining us tonight. We're looking at Mars, then we're going to go back to Jupiter and Saturn if we get lucky with the clouds and precipitation. Humidity is still okay. Precipitation is still off to the west, so we are still okay. Let's take another look here. I adjusted the focus. I don't know if I went the right direction or not, so we'll find out. There we go. Okay, so that's a better focus, but unfortunately Jupiter is just way too bright. I mean Mars, pardon my spoke there. There's my sun. So just to focus a little bit more. My son is singing some, but there's Mars. This actually looks pretty good. And set time is in 15 minutes. All right, so let's go back to Jupiter and Saturn. After all, they are the stars of the show tonight. And let's hope for a break in the clouds. It's good to touch up the focus so while we're here on Mars. All right, so I need to zoom out. A little bit hard to make out the surface structure with the artifacts there in our detector, but with Mars, with our Campus telescope, you can see a little bit of the fact that there's some bright and dark regions on the surface. Okay. Yes. Okay, let's watch the telescope slew to darn near the horizon. Here comes our webcam view. Feel free to jump off if you're bored, but welcome if you've joined us late and haven't seen Jupiter and Saturn yet. We're going to take another look. And feel free to ask any questions you have in the chat. While the telescope's moving, let's take a quick look at our camera. You see the domes in a way. It looks like there's still some clouds there off to the, oh, that's the wrong horizon. Okay, let's look at the bottom horizon here. We might get lucky. We'll see. I think that's actually Mars in the web SkyCam view there at the moment. How we doing? There we go. You can actually see the back of the primary mirror of the telescope coming into view at the moment. You see that silver cylinder right there. That is a third mirror that directs the light to our digital cameras. We're going very close to the horizon. Can you point out in the night sky map where the moon and Mars are in relation to Jupiter and Saturn? Yes, we could definitely do that right now. So let me just orient this a little bit better. All right, so this is this is like if you were in the ground looking up. I've zoomed way out here. The sun is below, it shows below the horizon too. So there's the sun below the horizon. Here's Jupiter and Saturn, pretty much west-southwest as they're on their way to setting, following the sun. And if you kind of draw a line from the sun to Jupiter and Saturn along what we call the ecliptic, following the signs of the zodiac, Capricorn, Aquarius, Pisces, Taurus, Aries, you get to Mars right there and the moon right there. So the moon is pretty much due south. Mars is pretty much due south, about fairly high up in the sky. And you just want to look to the west to see Jupiter and Saturn. At the moment, they are 7 degrees above the horizon as the Earth turns. Let's go ahead and take a look and see what we can get. Do a fairly short exposure in H alpha. Fingers crossed. My guess is this little bright region of Mars is one of the poles of Mars, but I don't know for sure. Zooming out. Oh, they're a little bit off, so let me adjust the pointing, and they're pretty dim. So let me change filters. So it looks like they're getting close to the horizon, so we're definitely looking through some clouds. But you can see them there. There's Jupiter and Saturn. So I'm going to do a slightly long exposure in a different filter to hopefully get a cleaner look at them. Different color, basically. So our telescope pointing is a little bit off. It thinks Jupiter and Saturn are here on the left, so I just told it to move them to the left on the screen here, and we should hopefully get a good look at them now. There they are. Looks like the focus is actually pretty bad, but we're also looking through a lot of the Earth's atmosphere. So we'll start here. Let me adjust this view. Yeah, the focus is pretty bad. So let me try touching up the focus. But anyway, here's Jupiter, its moons. They've moved, if you're paying attention. Let's go back to the, from even just a couple hours ago. Let's go ahead and zoom in on them right now. This purple square shows roughly the field of view that we're seeing with our camera. And so we have Ganymede's awfully close to Jupiter, so we still have Europa. Now we have a star over here that looks like it's in the line, so that's not it, but we have some other stars there as well. So they haven't moved that much, but let's try adjusting the focus. Whoops. And there's Saturn. I'll give you one more look at it there while I attempt to touch up the focus. All right. I go the other way because we had a good focus last time. We're very close to the horizon, so we have to adjust the focus of the telescope. What does that mean? We're moving the distance between the secondary and primary mirror, and it's like moving your glasses in and out. And so it changes if you wear glasses, you know what I'm talking about. So we're adjusting the position of the mirror, the distance between them to adjust where the light hits the digital camera. Oops, no, I did not want to do that. Abort. Wrong button. All right, it's pretty fuzzy, and I think it has a lot to do with the horizon we're at. Let me move this to the left a little bit more. We're just getting really close to the horizon. Move that out of the way. Do another exposure. So this close to the horizon, things are going to appear fuzzier as we're looking through more of the Earth's atmosphere. So not as crisp as of the view as we had about an hour ago. Okay, there we go. This actually does look like a better focus. I might just leave it there. Let's take a look, and Jupiter is pretty saturated, but we can adjust it a little bit more. And we could drag this around. Let's see, if we throw the contrast up, you can bring out the moons. Whoa, a little too much there. Oh, and you can just barely see, I think it's Ganymede right there next to Jupiter. And let's go ahead and readjust that. Let's take another exposure. This time we'll do a shorter one. And we'll go take a closer look at Saturn. Okay, so these are live views. Let's show the high contrast view. A little too high contrast. Let me move this window out of the way. And so we have Europa. I forget which one's Io and Callisto, and then Ganymede's kind of tucked away in the glare of Jupiter now. If we go to our virtual view of the planets, you can let's zoom out one level here. Yikes. Not what I intended to do. Yeah, so Ganymede's fairly close. And let's see some of the moons of Saturn again. Scroll up a little bit. We should be able to pick out Titan up here. And I have to play with the contrast a little bit. A little too much there. Okay, so let's adjust this. Yeah, so Titan's pretty faint at the moment. Must be some clouds or bad focus, one of the two. But the focus actually doesn't look that bad. Let me go check the focus real quick. Yeah, the focus is not great, but we're very low to the horizon. Okay, this little structure you see is not real. That's scattered light. Let's go ahead and take a closer look at the planets in turn. First, we'll start with Saturn. There it is. We have some artificial structure there in our detector. I wonder if it's moisture because of the humidity. Let me do a humidity check. Yeah, humidity is getting a little bit high. Zoom out. We're also very close to the horizon. Let me bring this down. Yeah, we're having a harder time making out the rings at the moment. And if we go down and look at Jupiter, there's Jupiter, and Jupiter is very bright. Whoops. Yeah, so we're seeing more of our detector artifacts where Jupiter and Saturn are at the moment. Definitely looking like we have some moisture at the moment as we're really close to the horizon. Take one more quick exposure. Yeah, okay, so I think that's going to conclude our show for tonight. We're going to have to close up our telescope in a minute, but let me just leave you with one final image of the Jupiter-Saturn double planet. I encourage you over the next few nights to go out right after sunset, look towards your western horizon, and you should be able to see this double star. And if you have a pair of binoculars, you'll get a wonderful view of Jupiter's moons and Saturn's rings over the next couple of nights, or even if you have a small telescope, you'll need a fairly clear view towards the horizon to see them. But there are Jupiter and Saturn. Oh, and I was going to show you a star. Well, all right, okay. One last fun thing, but we are going to have to close the dome soon. One of my favorite things to look at is the Orion Nebula, and we'll go take a look at that right now if it's sufficiently above the horizon. Let's take a look. No. Okay. We can go take a look at the Pleiades, and that is up, and that is a cluster of stars that are about 100, an open moving group of stars that's about sorry, accidentally was muted. Let's go take a look at the webcam as we move the telescope. There it goes. It's hard to get a sense of scale as to how big this telescope is, but right there is an eyepiece to look through. And you can see the white wall is actually cinder blocks. You can kind of make out the cinder blocks there. We see one of the motors that moves the telescope up and down in the declination axis, very similar to latitude on the Earth. And the big fork that's turning now is very similar to repointing the longitude. Hey, thank you for the note. Tonight was amazing. That's fantastic. I'm so glad everyone could join tonight to celebrate this once in 8th century event. of the conjunction of Jupiter and Saturn. It's a wonderful winter solstice. May your days be longer from here on out till we get to the summer solstice. Looking at the all sky camera real quick, it looks like we have a dome blocking the view, but we presumably have a decent amount of moisture. So we're going to have to close this up soon, but let's go ahead and take a look when our telescope is in position. It's still on its way. Thank you, everyone. Glad you could make it. So we're going to look at the Pleiades. The Pleiades are also known as the Seven Sisters, and they're in the constellation of Taurus, the shoulder of the bull. And they're, I forget how far away they are, about 125 parsecs. So around, I think, or no, is it 60 parsecs? I can't remember. Anyways, around 400 light years or so, give or take. Here's our dome rotating. Here's a nice view in the webcam. Now you can actually see the telescope through the opening in the dome. So that gives you a sense of scale with the door there looking through. I hope you're all healthy and safe during this pandemic as well, and taking care of yourselves. It's been a dumpster fire of a year of 2020. And let's go ahead and take a look at the Pleiades. All right, so I'm going to do a 5-second red exposure, and we'll take a look here. There's Jupiter and Saturn one last time. There we go. There's the Pleiades. Doesn't look like much. Let me tune it up for you. Oops, a little too far. So this is a cluster of stars. I'm going to draw out the contrast there. And if we go to our virtual view of the night sky and zoom in, here's what it looks like with the Hubble Space Telescope. So pretty darn nice. So we're not seeing this diffuse nebulosity that's glowing and reflecting light, but we see a cluster of stars, a bright one. So that's Alcyon. And that's what we're seeing right here in this live view. There it is. Now we see this trio of stars. So Alcyon is one of the Seven Sisters. We're not seeing all of them just because they're actually fairly spread out. I mean, you can actually see the seven stars, and we're super zoomed in. But this is a cluster of stars, and I promised to show you how a star looks different before we wrap up. Let me go back to this virtual view, get oriented a little bit. Yeah, okay. So this is one of the Seven Sisters. There's two of them off over here. And then that's about all we have in the field of view. There's one bright one over there. Is that visible? Yeah, so this is another one of the Seven Sisters up here to the right. So let me zoom in. I think this one's saturated. Yeah, so let me zoom in on one that's not saturated to give you an idea of what that looks like. And how's the focus? The focus is great, actually. Good. So even in a telescope this big, individual stars just look like dots. Stars are so far away that it requires a specialized technique to actually resolve their surfaces using multiple telescopes in a technique called interferometry. Now this looks like a bright blob because of how I displayed it. That's not the physical size of the star. That's actually the blurring from the Earth's atmosphere. And if I change the stretch on this screen, you can see that as we go in closer and closer, we can see it's just a bright point of light. And this is zoomed in all the way now. Let me get that back. And so all of the distribution of light you see here, you can see it's slightly elongated up and down. That's our optics combined with the conditions we have. So that's not real. It's not astrophysical. It's related to the Earth's atmosphere. If I do one more quick exposure, you can see it might change a little bit. It also might be the focus not being perfect, but it's actually a pretty good focus. But now we're zoomed in on the individual pixels. You can see it changed shape a little bit, right? So our focus is a little out of whack. We might be actually seeing some oscillations in the telescope, actually. And so this spread in the light from an individual star is due to the blurring effects of Earth's atmosphere. And so if you have something called adaptive optics or can go to space, you can get much crisper images of the night sky. And that's why we have some beautiful views from the Hubble Space Telescope. But even with the Hubble Space Telescope, even the biggest, closest stars are still just single points of light. So that's our show for tonight. I want to thank everyone for joining. I got to go have some dinner. I'll leave this view up of the Pleiades. Thank you for joining us. Come back in February for our public evening under the stars. We also have lectures with the Smithsonian Associates program. Please follow us on Twitter at GMU Observatory is our Twitter handle, and you can find out more on our website at science.gmu.edu/observatory, and that's where we'll be posting a link to this video as well. Oh, thank you from Massachusetts. Thank you everyone for joining. Have a great night.